Now that we've had a chance to define the inverse and kind of think about the theory behind the inverse, let's go ahead and actually talk about how we would find a inverse if you're given some matrix A. Now, this is not really an easy process, and so I'm going to give you kind of an example of how this might work, and then we'll go into the actual details on how to do this a little bit more efficiently. So let's just say, for example, you were given a matrix. Let's call it A equals 3, 1, -4, -3. And then I said determine A inverse. Now, here's probably what you would do. You know that A inverse has to be a 2 by 2 because your final answer needs to be a 2 by 2 identity matrix. So you would say, well, let's just say A inverse has the form A, B, C, D. And then you might say, well, let's take A, which is 3, 1, -4, -3. Let's multiply it by A inverse. And this should give me the 2 by 2 identity matrix. Easy enough. So now you start multiplying and you get that 3A plus 1C is the first spot. 3B plus 1D is in the second spot. -4A minus 3C, -4B minus 3D. That's the left-hand side, and all of this has to equal 1, 0, 0, 1. So you start going through the possibilities. 3 times A plus C has to equal 1. So, okay, there's some options here. You might start guessing, well, A is 1, C is -2, etc., etc. But the problem is this also has to satisfy the equation -4A minus 3C equals 0. And now you're looking at this, and this is actually a system of two equations with two unknowns. And then we also would have this system of equations with two unknowns. And so you would go through the process of solving these. Maybe you multiply the first one by 3. So we get that 9A minus 4A would be 5A, and then the C's cancel out, equals 3. Okay, so A is the obvious number of 3/5, just like we were all guessing to begin with. Then you go back in and solve for C. So this is turning into quite the process. And there's actually sort of an easier way of doing this and actually proving it that I haven't gotten into yet, which we will come by later on. But because I don't necessarily want you just solving a ton of systems of equations, I'm going to give you kind of a nice formula for finding the inverse of a 2 by 2. And we'll spend more time with 3 by 3s later on. So let's just say we're given a matrix A, and I'll go back to A, B, C, and D in this case. Then its inverse, if it exists, which I'll come back to later, is in the form D and A switch, and then B and C are in the same spot, but they take on a negative. And then out front, I've left a little room. There's actually a scalar multiple of this matrix. It's 1 over A times D minus B times C. So it's important to have the spots correct, so D and A switch, and then also the B and C become negative. But then it's also important to actually scale this by 1 over A times D minus B times C. Otherwise, you might get the identity matrix, but it might be like 5, 0, 0, 5 instead. Now, this only works for a 2 by 2. If you go up to a 3 by 3, there's sort of a formula for it, but it gets pretty convoluted. So we'll leave the 3 by 3s for another day. Today, we're just going to focus more on 2 by 2s because it's something we can actually do pretty quickly. So this is a formula you should have written down. Every single 2 by 2 matrix, this is its inverse. So let's go ahead and do an example. Let's determine A inverse and show that your answer is actually the inverse. And then the matrix we're going to be doing this for is the one we just had to start with. I'll write it again here. 3, 1, -4, -3. Okay, so this is sort of a two-parter. A is determine the inverse, and then B is to show. So the easier part maybe is just first determining A inverse. Now there's a couple ways to do that. Well, no, there's one way to do it, and then I'll talk about the final answer. So to find A inverse, we're first going to need to figure out what A times D minus B times C is. So let's go ahead and do that. 3 times -3 is -9 minus 1 times -4. So I get -9 plus 4, so I actually get -5. So now I know that A inverse is going to be 1 over -5. I'm going to flip D and A, so it'll be -3 and 3. I'm going to make 1 negative, and I'm going to make -4 negative. And so that would actually be the answer. Now I'm totally fine with you leaving your answer like this. This is fine. I think this is a good way to illustrate the structure of the matrix, and you don't have to keep writing fractions. Or if you would prefer, and Delta Math actually will require it this way, you could do, you could actually distribute that -1/5 to each term. So -3, -1, 4, 3. So I'm actually going to take that -1/5 and distribute it using scalar multiplication. So then my final answer becomes +3/5, +1/5, -4/5, and -3/5. So if you prefer that, that's okay. I kind of think that this other one is a little bit cleaner to write out, and it displays the structure of the inverse, but either one is fine. Okay, now that we have a formula for the inverse, let's actually go ahead and solve a problem. Just like we would do with a linear equation, we're going to solve for x, except now it's going to involve matrices. So we're going to solve for x in this equation below. We're going to say we have the matrix -2, 1, 3, 0 times the matrix x minus the matrix 1, -1, 8, 7. And then all of that is going to equal -20, -1, 12, and -6. So this is the equation we're going to solve, although I just realized I forgot to do part B in the problem above. So part B, we would actually have to show that this was true. So I'll leave all of you to do that. You can double check that that actually works. But I'm going to go on to this problem and solve for x. Okay, now if this was like a linear equation without matrices, we might say, well, to start off with, I know at some point I am going to have to add this matrix here, and I'm also going to have to divide by this one here to both sides. But we know that division doesn't work, so we're actually going to multiply both sides by the inverse of that first matrix. So in order to make this look a little bit cleaner, I'm just going to say, first I'm going to erase this stuff that I wrote. But I'm going to say, let's let this be A, let's let this one be B, let's let this one be C. So now my equation looks like this, which just looks a little bit cleaner. So once again, if this was a linear equation, you might say, well, if I'm going to solve for x, I would need to first divide both sides by A, So I'd have x minus b equals c over a, and then I would have to add b to both sides. Since we are working with matrices, though, we're actually going to do this a little bit differently. So step 1 is going to be multiply by A inverse. Now we even have to be a little bit careful with this, because if I multiply the A inverse over here, that doesn't actually give me 1, or not. This is not equal to the identity matrix. Because remember, matrix multiplication, as we saw before, is not commutative, so I can't just flip things around however I want. So what I'm actually going to do instead is I'm going to multiply A inverse over here, so that this will actually give me the identity matrix, but then that means I have to multiply this side of C by A inverse. It's very important to do A inverse times C. This is not the same as C times A inverse. Very, very key point right there. Okay, now in order to do this, we need to find A inverse. So let's go ahead and do that. A inverse equals, I'm going to flip, well, let's see, 1 over AD minus BC is 1 over negative 3. I'm going to flip my 0 and my negative 2. And then I'm going to make this negative 1 and this negative 3. So there's A inverse. Based on its construction, I know that my new equation is just going to be this. I do need to figure out what this is over here, 0, negative 1, negative 3, and negative 2, times my C matrix, which was negative 20, negative 1, 12, and negative 6. Just confirm that. Yep. So I'm going to have to go ahead and do that. Now on the left-hand side, I'm just left with x minus b, because anything times the identity is just going to equal itself. On the right-hand side, I have to go through and actually calculate this. So we're going to have, I'll leave the negative 1 over 3 out front for now. I'm going to do this multiplication, so it's going to be negative 12, positive 6, 60 minus 24 is also positive 6, and then 3 plus 12 will give me 15. Distributing that negative 1/3 in there, I actually get the matrix 4, negative 2, negative 2, and then negative 5. Just let me double check this real quick. Yes, looks good. And then I'm going to now add b to both sides. There's nothing I have to be careful about here. Adding matrices works out the same way we would like it to. So I end up with 4, negative 2, negative 2, negative 5, plus the matrix B, which was 1, negative 1, 8, 7. So then I get the final answer of 5, negative 3, 6, and 2. And that would be my final answer. All right. So this one does take a little bit more work because you're actually finding the inverse and then multiplying and adding matrices. The key point, I can't emphasize this enough, is when you're doing that first step, make sure you multiply the correct side by A. In this case, we multiply the left by A inverse of both A and C, as you can see in this very crucial step right here. Right here, sorry. This is really the crucial step. The rest kind of follows how we want it to, but please make sure you're doing this correctly when you try out these problems in Delta Math.